My face above the water, my feet can't touch the ground, and it feels like I can see the sands on the horizon every time you are not around. I'm slowly drifting away, wave after wave, wave after wave. I'm slowly drifting, and it feels like I'm drowning.
Oscillatory motion. So what is it? Oscillatory motion is a repeated motion. So an example of a repeated motion would be like a wave, obviously. So when we're talking about waves, we have simple harmonic motion. Simple harmonic motion is a type of oscillatory motion, so this is an example of it. A simple harmonic motion has three basic things that it does. The motion always goes back to equilibrium. Motion goes back to equilibrium. That means it'll swing on one side, go to a certain point, and then it goes the other direction. That way the displacement is always going to be proportional to the restoring force. So it's going to go up one side, back down to the middle, and then up to the other side. Think of a pendulum swinging, or of our Newton cradles that most of us have in our classrooms. Swings from side, goes to the middle, and swings to the other side. The next thing is that simple harmonic motion always follows the same path. Finally, simple harmonic motion, it oscillates around the equilibrium. So it's very similar to the first one. It goes around the equilibrium. Oscillates around equilibrium. Okay, now that we have a handle on oscillatory motion and simple harmonic motion, let's look at waves. Begin with, what is a wave? Well, a wave is a motion of a disturbance. It is the motion of a disturbance. Waves only transfer energy. They don't transfer particles. So they only transfer energy.
One really important thing to remember about waves is they only transfer energy from place to place, not any matter. And we can see that here by looking at a lovely rubber duck sat in a bath. As a wave goes through, the duck bobs up and down, but once the wave's gone, he's back to his original position. The wave has carried energy through, but it did not carry the duck with it.
Is the material through which a disturbance travels. So in other words, a medium is what the waves are going to travel through. Some waves require mediums and other waves don't, and we're going to go over both of those kinds. Now the medium is going to be what determines the wave's speed. Medium, it determines the wave speed. And we'll talk about that just a little bit later. We'll get into more detail on that.